Alright, now I'll talk about how I arrived at that 0.7 available static pressure. Well, I had a 2.5 ton unit, so I need 1000 CFM. And, plus or minus 50 per ton. And being the higher that you go, the more efficient it will be. The lower you go, the more humidity you will pull out of the air. So this is the air handler that I'm using. And you'll notice I'm over here on high 1. This is the highest. This is got an X13 motor. And so if I go over here and you see I want to hit 0.5, that's the recommended maximum by the manufacturer, and all manufacturers use that value. I've seen one Linux in my life that said 0.75 as its recommended maximum. So I follow that over to 0.7. See if I can zoom in. Sorry about my jittery camera work. There it is, 1030. So that's the value that I use for my CFM. The reason there's 1230 there is because we were deciding on which equipment to use. And I misspoke in the last video and said that it required just under a ton and a half. It requires just under 2.5 tons. But you can take that information that you saw on the chart in the book with the corresponding external static pressure and CFM to fan speed, and take that and plot it right on a chart like you learned in elementary school. And that's what you get. That's called the fan curve. You can do the same thing with your ductwork, and you create a duct curve. And you can superimpose them on one another, and hopefully I can find that quickly. And you get the operating point. And that tells you it all. That's going to predict where your CFM falls, what fan speed you're on, because you can do all 3 fan speeds, and there's an illustration of that in the book, but I'd have to find it. And so it's got your static pressure, available static pressure, your CFM, and where the two intersect is where it is going to operate. Sorry about the turd in my mouth. There's one for coil pressure drop. So as CFM increases, the pressure drop of the coil increases. That is true of all your devices, even your duct fittings. However, in Manual D, you assign pressure drops to airside devices like coils, filters, dampers, grills, registers. Duct fittings, you assign equivalent feet to, and that is just to simplify the process. And actually, that is always supposed to be a worst case scenario, as long as you follow the maximum velocity rule, because it's all judged at 900 feet per minute. So below 900 feet per minute, you're going to find that those equivalent lengths will actually get shorter. So this is just a way to ensure a safety margin. So as long as you keep everything within the parameters, you're going to be fine. Here to illustrate coil pressure drop and how it changes with CFM increase. Pressure drop also increases. So let's just pick one. So this coil at 1000 CFM dry, it's got a 0.074 pressure drop, and wet, it's got a 0.081. Well, let's move up and decide and see if we'll pump 1500 CFM through it. Well, dry, or what? I'm sorry, dry is 0.18 and wet is 0.220. Okay, let's finish up by going back to this chart. Now, just to the right of what we talked about before, the design CFM and how to figure out CFM before that, over here you've got your sizes. So you use your ductulator and use the CFM value at that friction rate, and then determine which size. Of course, you're going to have to round up when you come into, intermediate between sizes. And then the next thing you would do is check the velocity. So all these are pretty low because 0.06 is going to do that for you. So this one's at 400 feet per minute. Well, that's within range. But say if you got something that said 900 feet per minute and it was a branch run, well, you would know that's wrong, and you would have to increase the size of the pipe to match the velocity and not the friction rate, because you got recommended and maximum velocities for supply and return sides, and returns over here. But just for the sake of argument, we'll ignore the return for now. Trunk ducts are 700. Flex, you can just always remember the maximum. Oh, I'm sorry. Let's go back to just trunk ducts. 900 is the maximum. Supply outlets are always maximum of 700. My maximum is 500. Then for returns, it's saying maximum 700 for flex, and recommended is 600. And your grill is saying is maximum 400. I agree with that. Return grill face velocity 500. Actually, I think it's a little high. That is the maximum for sure. It'll start to sing after that. Filter grill, yeah. So around all your filters, you want to maintain a velocity of lower than 300 feet per minute, and otherwise your pressure drop is going to be way too high for that filter. But that's how you arrive at the final size of each run, and the trunks. Alright, I'd like to just say that a little bit I've shown you about this is certainly not enough to just take a YouTube video and know how to install ductwork. That wouldn't be fair to you or your customers. You probably, if you're in this business, you invest money in tools all the time. I've said it before and I'll say it again. You've got to have the right tools. You either got to get this book or get this book, and also the software that I've shown, the load calculation and all the stuff that goes with it. That's the new one. That's probably the one you'll get. That software and all this can be found at acca.org. I'm not affiliated with them in any way other than I'm a member. And you get discounts for being a member when you buy stuff, so I highly recommend it.